From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 339, recorded live Tuesday, October 2nd, 2012. This episode is brought to you by Telerik, offering the best in developer tools and support. Online at telerik.com. And by Franklins.net, training developers to work smarter. And now offering GesturePak, a powerful gesture recording and recognition system for Microsoft Connect for Windows developers. Details at gesturepak.com. In this episode, Scott talks with Jez Humble and Martin Fowler about continuous delivery.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and I'm here in Denmark at the GOTO Conference, and I'm sitting down with Martin Fowler. How are you, sir? And
pretty good.
Jez Humble. Jez Humble has written the book on continuous delivery along with David Farley. How's it going?
Great, thanks for having me.
Is it okay to say you've written the book because you've written a book?
Sure, that works fine.
I think it's somehow more impressive to say you've written the... Have there been any other books on continuous delivery?
Not specifically, no. I think this is the first one.
There's a continuous integration book that was an earlier book in my series, but that, as we'll explore later on, that's not quite the same thing.
Okay. So continuous delivery is a really interesting topic because it's fun to say and it's a fun buzzword and everyone's bought into the wisdom around continuous integration. Obviously, the next step is to deliver stuff continuously. And in the book, you talk about a number of different things around creating a pipeline, a deployment pipeline. But as someone who had done similar things, while I hadn't named them in 2005, 2006, the thing that struck me the most was that doesn't it seem like it is simply the will that is required to do this more than it is the process?
Yeah, I think that's a very astute observation. And I think you're quite right. None of this stuff is really that new. And it's stuff that we were doing in around the same time period. And other people in Silicon Valley were doing, the IMVUs of this world were doing continuous deployment around the same time. And I think what's different about those companies is, like you say, the will and the need, the necessity to actually get stuff out there quickly and get feedback on it quickly. So it kind of came from a business imperative. And also just from the fact it's so frustrating to have to wait for such a long time for your code to get out there. It's partly just reducing misery or, the converse, which is improving your happiness as a developer.
Mm-hmm.
Yeah, I remember one of my earlier involvements with it was when I visited Kent Beck when he was working in Switzerland in the late 90s. And they were doing this insurance system for extremely rich Swiss people. And they were pushing to production every night. And, they did that for a year, and once they had to roll back, and that was kind of normal. But the thing is that in that environment, Kent was in this really nice, small, talky environment. It was fairly straightforward to go through that push-to-production path. For our clients, that push-to-production path has minefields and dragons, some of which are technical, but the really muscular dragons are human, usually.
When did pushing to production become such a big deal? I mean, in the early 90s, I was developing software, and I don't remember a lot of fear around that. Somewhere in the late 90s, early 2000s, it became scary to put something into production. Is that a language reason or a cultural reason?
I don't know. I feel it's always been a big deal, but the thing was, in the past, it was only the thing you did at the end of the project. I mean, it's 2 years, and then we go to production. So, yeah, it's a big deal, but it's got a different context. But when you're saying to yourself, well, we want to build this software in tiny increments of user-valuable features every few weeks, and as soon as possible put them into production, and then continue putting stuff out, then it becomes a whole big deal, because a process that's going to be okay to do once every 2 or 3 years is not what you want to be doing every week.
And I think the other thing is that people naturally equate release with deployment. You think it's the same thing. We're going to deploy to production, and that's when we release our software. And I think one of the things that I've realized is actually really important is to distinguish between those two things. One of the things that Facebook talk about, Chuck Rossi gives a talk where he talks about how every major feature in Facebook for the next 6 months is already in production. You just can't see it yet. So they've separated release and deployment. They're deploying once a day or now twice a day, I think, Facebook into production, but they have a lot of the features switched off, or they actually have a piece of software called Gatekeeper, which controls who can see which features. So a lot of those features are only available internally, and then they dial them up to 1% of users, or everyone. They have different toggles for different people, so they can say this feature is available to everyone except TechCrunch editors. They actually have a toggle for that. So
I support that idea. Including the login feature. I think that would be nice if TechCrunch was unable to use that feature.
So they can control at a very fine-grained rate when features are released to users, but that's completely decoupled from deployment. It's a completely separate activity.
So it was the addition of frequency that made deployment a big deal? I mean, it's okay that deployment's happening at the end of 2 years because we're releasing software, we've been working for 2 years, there'll be some manual steps. Why would we automate something that was done once?
Right.
And then suddenly we're releasing and or deploying, once a week, once a month, once a quarter, once a scrum, however you want to phrase it. It seems to me like it's a natural computer science thing to, if you do something twice, automate it. But today, in 2012, there are still people who are dragging their websites from a folder into a FTP program. And the thing I don't understand is the second time they do that, some alarm doesn't go off in their head that said, stop, that should be a script.
Right, absolutely. And I think what you saw is that it was web companies who started doing it. I mean, I was doing continuous deployment in 2000 when I was FTPing files from my workstation directly into production, which is not something I'd recommend now necessarily. But I think Flickr were really the people who most visibly pioneered this back in 2009 when they gave a talk at Velocity about DevOps cooperation, and they just calmly said, "Oh yeah, we're deploying 10 times a day into production." It was just the way they started off doing it because it made sense to them.
I think another thing that's made a big impact here is the testing culture. When I think of when I kind of started in this game, testing was something you didn't even think about doing until you'd finished coding. And the idea that we do testing continuously as part of development, I think also makes a good bit of this more possible because you begin to realize, well, the code can be completely tested, even if we are building in increments of once a week. We don't have to kind of go through a phase to make it good enough to deploy.
Given the amount of computing power that we have available to us, whether it be on our laptops and desktops or whether it be in the cloud, is there really anything we shouldn't be doing continuously?
No, I don't think so. We talk about continuous testing, and that applies to exploratory testing and usability testing as well. We should be doing usability testing continuously. People talk about doing code reviews, and one thing that I often say is that pairing is continuous code review. So I think continuous feedback, getting features out to users and small iterations of features, this whole idea of the lean startup, that you come up with an idea, work out what the smallest possible amount of work you can do to test that idea is, get that small increment out there, get data back, continuously getting feedback from our users. I think it's a very widely applicable concept.
Yeah, I never ever say never. So there's probably some cases somewhere, but I think what we've done now is flipped the default. The default now is continuously, and that has a lot of consequences. I remember a conversation I had once with a guy who was very big in the SOA world, and he was calling me up talking about patterns and stuff and saying, well, it's really important with services that you have because it's so hard to change the contracts of these services, you have to really nail them down and get them right before you actually put the services deployed. And it really struck me at that point on how my worldview and this guy's worldview were at such complete odds, because I'm always, how do we make it easy to change? How we can make this continuous movement going on? That's just my default way of thinking now. And I think that's the shift, is more and more people are beginning to think of this idea of continuous change as a default.
It goes all the way through the life cycle. So people are doing continuous design. UX people are thinking about how they can continuously iterate their designs in response to user feedback. And even business people are thinking about, and I think that's a really radical change in this, not necessarily the technical change, but the interface between business ideas and IT and your users is changing that whole relationship. Instead of, someone once said that our job as developers is to take business ideas and turn them into measurable customer outcomes, which I think is a brilliant phrase. And I think if you're doing continuous delivery, what it means is instead of the business coming up with a 6-month bunch of requirements and throwing it over the wall, instead IT is saying, what should we try next? And the business people are coming up with ideas. How do we test that? Let's run this test and get the information back. And then what should we try next? You're always asking, what ideas should we try next? And that fundamentally changes the relationship between all the people involved in building software systems.
I think that changes everything, the idea of actual metrics. It's surprising that as software developers, we spend so much time doing micro benchmarks of string libraries, but so little time A/B testing on whether or not this button converts to that button. For some reason, micro benchmarks are really exciting, but we forget as engineers that we're not just writing it to be fast or to be fun, but we're trying to support a business. So rarely I hear people utilizing techniques like continuous delivery to make more money for the business. They don't get excited about those benchmarks. Like, we made this button green and 20% more people gave us money. Like, other than Amazon, who else does that?
Yeah, and I think this is a deeper cultural issue that comes in. A lot of the time we tend to, the habit seems to be everywhere to treat developers and real people as completely separate islands. We mustn't have developers talking to the business people directly. Developers are only interested in their technical stuff. And like many things, there's some truth in that. A lot of developer people do get overly interested in the technical side to the detriment of the rest of the picture. But it's something that's reinforced and encouraged time and time again. And one of the key things right from the beginning of my involvement in the Agile community in Kent with XP was we really want to break that and get people coming together so that it's actually not just business people who are coming up with ideas for how to improve a software product. It could be the developers. And as a result, the ideas can come from anywhere. And I think this is going to be increasingly the case now as we get to do all of this big data stuff, because a lot of things are in the developers can come up with are things that business people aren't even going to think to ask for. And they're sometimes remarkably simple things. And it's really important, therefore, to increase that level of collaboration.
And I think there's a virtuous cycle here. I think part of the reason that developers are more interested in the technical side than the business side is if they have to wait a month or 6 months for their stuff to go live, that feedback loop's so slow, it's really hard to be interested in it. Whereas if you're deploying and seeing the effects of that, that actually becomes really interesting to you as a developer, and it encourages developers to think a lot more about that stuff. And so that virtuous, and you see that in organizations that are doing this, developers become much more focused on running these kinds of experiments, and it's exciting for them. And that enables much more cross-functional behavior and developers being much more engaged in the business side of things.
So that's interesting because I've always made, with all jokes, there is truth. And I've always said that one of the things that drives developers is selfishness, to work on the things that they want to work on, and laziness. The very best developers are truly, truly lazy. And, anytime I see myself doing something more than once, I try to automate it. So what you're describing in very kind of, I would even go so far as to say suit-friendly terms, like it's a virtual cycle that supports the business. Really, as a developer, I'm hearing about, it's okay to laugh. I hear you guys laughing, but you're not.
No, it's just the thought of Jez as suit-friendly. Well, you're not seeing how he's dressed on the radio.
I'm not wearing a suit, but
he does have pants, though, and that's very lucky for us. But
especially if you're English.
That's true. But you're saying, virtuous cycle, support the business. But really what you're saying is we finally set up a system that will make lazy developers work on those things that they selfishly want to work on.
Yeah, and some people have been experimenting very forceful in this idea. There's an ex-colleague of ours, Fred George, who's I think you can find some of his talks on InfoQ and the like. And the company he's associated with, they try very much to set broad business metrics and then say to the developers, do whatever you like, just improve these metrics. And his claim is it really does engage and get people going. Now, who knows what the full reality is that, though, but I think the promise is really quite interesting.
This episode of Hansel Minutes is brought to you by Careers 2.0 and our friends at Stack Overflow. If you're not familiar with Careers 2.0, it's the job site within Stack Overflow that helps you advance your career as a programmer and host a portfolio of all your work. You can search through job listings or create a profile to show off the work you've done and let employers find you. Careers 2.0 lets you showcase real coding samples by importing answers that you've posted on Stack Overflow, open source contributions from GitHub, Bitbucket, and SourceForge, or blog posts you've written. Even if you're not currently looking for a job, your profile can still serve as a terrific representation of all your programming knowledge. But don't worry, unlike other sites, you won't get spammed by recruiters. You'll only find qualified employers here. Careers 2.0 profiles are also invite-only, so the community stays top-notch. And as an exclusive offer to Hansel Minutes listeners, Stack Overflow wants to help you jumpstart your job search. The first 200 people to sign up for a Careers 2.0 profile will receive a limited edition Stack Overflow branded Padfolio. So head on over to careers.stackoverflow.com/HM. That's careers.stackoverflow.com/HM. Sign up today. Just make sure that you include your mailing address so you can receive your free gift. Once again, that's careers.stackoverflow.com/HM. One of the things that you comment on in the book is the importance of a delivery team that is from multiple disciplines, but is focused on one thing. You don't just say, have a build guy. You almost have like a council of deployment, and you've got a database person and an ops person, and they all work as a team. That seems a little bit difficult, though, because you're basically using kind of like aspect orientation, and you're slicing through the organization, and you're saying, we all have to agree this is important, so everyone needs to agree and then send a representative, and then do whatever it takes to remove that friction.
Yeah, one of our principles in the book is that everyone is responsible for delivery. That's one of our kind of top 8 principles that we talk about. And I think that's very important. Part of the problem, part of the root cause of this problem is the fact that developers don't consider themselves responsible for what happens in production. And that means they write crappy code that doesn't actually work in production. And I think a big part of this is aligning responsibility with the power to actually change things. You know, if the operations people are getting it in the neck all the time when the site goes down, but the developers don't feel any pain, people don't change unless they feel pain. Obviously there's the carrot and the stick, but I think a big part of it is saying, well, we're all responsible for this. And if you make developers carry pagers and they get called out when the site goes down, that tends to encourage them very effectively to write much more production-ready systems in my experience. I think the other thing that is important is to say that if you look at the way that companies are organized, a lot of them are divided according to functional silos. That makes sense when you have these really long delivery cycles and you're working in big batches, because you can optimize for individual functional silos doing their part very well. When you move to a process where you're optimizing for cycle time, or lead time, in fact, I should say, time from idea to realized business value in production, the way to do that really effectively is to reduce batch size. And when you're reducing batch size, it's just wildly inefficient to have functional silos and handoffs. And so the only way really to effectively optimize for lead time is to have cross-functional teams and focus on how do we get stories from start to finish as fast as possible. And many interesting consequences follow when you actually change your process in that way.
Yeah, it's been one of the long-running questions for quite a while, that should we organize organizations by sort of the activity and skill that you do, or should it be organized in terms of some more domain business outcome? And we find it in people, and also we find it in code. Should we organize our code's major divisions by database versus UI, or should we make it in terms of more functional pieces? I've always gone for the latter, because that focuses everybody's mind on some useful business or domain purpose. And I think that's the way you want to orient everybody. Now, it does have disadvantages. It does mean that you get a less fertilization of ideas within a particular skill group. It also means you may have to have some limited utilization. I mean, you only really need a database guy half the time, but you want him full-time on the team because you can't afford him thrashing between 2 teams. But again, I think this is also the thinking that comes out of the lean thinking. It's better to have slack in the system and underutilized resources in order to do that cycle time. And I just did the most evil thing in the world. I just referred to a human being as resource.
Naughty Martin.
Oh, no.
Buy a round of drinks later on, I think, for that. But I think this is one of the things that's very important, is you have to... And in fact, you can prove from Q theory that when you optimize for lead time, you sub-optimize for utilization. And one of the problems with traditional project management theories, which work on cost accounting and optimize for utilization, that creates the most inefficient process you possibly can for actually getting software from idea to production. And so we have to change our mindset about this. And slack time's really important. Those people who aren't working on features, they're the people who are keeping the system working. And, for the one-line definition of continuous delivery, it is prioritise keeping the system working over doing work. And to keep the system working, you need people who are working on things like making the automated tests more efficient, or automating the deployment process, or simplifying the deployment process so that we can automate it efficiently, or working on how we do the infrastructure management. You need slack in the system to be able to do those things to keep the process efficient.
When I go and visit customers and talk to customers and explain to them, you need to think about unit testing, or you need to think about continuous integration, which a lot of us take for granted. But I don't think a lot of us realize that the vast number of kind of dark matter developers are just barely keeping their heads above water, much less thinking about having slack time to go off and put together a system. I mean, how do you tell the chief architect of the Nebraska Department of Forestry that his system would be more effective if he could just take a week off and put in continuous integration when he's just trying to keep the system running?
Yeah, it's a difficult problem, and I think firstly you have to just provide people real examples of how this has worked in practice, and I think a big part of what we do is just letting people know that there is a better way to do things, and that it is possible to do things differently, and that it can actually work. And I think the key ingredient of change is people have to be interested in getting better at what they do.
But let me interrupt. But a lot of people say, well, that's great for you, Jez.
Right.
You use Ruby or Fancy Language .2.0, or that's great for you, Martin. You're Martin Fowler. But I work in Microsoft Access, or I'm still doing stuff in Clipper. It's just simply not possible to automate problem X.
I think often that is just in people's heads. And some of the great advances that have been made in computer science are when people have solved problems that other people thought were impossible just because they didn't know they were impossible. So there was a talk yesterday by Brian Cantrell where he kind of gave an example of someone who there was a new hire in the company, and they said, go and write a parser for this particular thing. And everyone knew it was impossible. And then they forgot about this guy, and he came back 2 months later and said, I've done it. And they said, But that's impossible. And he did it because he didn't realize it was impossible. And there's a story from Xerox PARC, which is similar about the kind of window redrawing thing.
Well, and that's how that's another way to really get programmers moving. And I know this because that's how my wife gets me moving. She just makes the declaration that it's not possible for this to be done this way. And then, of course, I can't sleep. I can't eat. I'm thinking about it in the shower, until it happens. The system that I mentioned that I was working on in 2005, 2006 was a banking system. And banking is historically a very kind of waterfall kind of a world. And for us, it went from waterfall to scrummerfall,
right?
Where we think we're doing Scrum, but we're really just iterating ourselves down the waterfall. But one of the things that we really did a great job of is we introduced continuous integration into a number of large United States banks to the point where we would do a commit, and a complete virtual machine with a runnable system would pop out the other end, because the business problem that we were trying to solve wasn't shipping the banking software, because that really only did happen once or twice a year. It was actually shipping a complete demonstration bank to a salesperson. Sales guy needed a new version of the system every month, and he was ending up getting one every year. How is he going to go and sell that if he only gets it every year? So we optimized our delivery system to deliver tiny Northwind Bank in a virtual machine. And the way that we finally got past that final hurdle, which was automation. We didn't realize that VMware had an automation interface. And once we figured it out, we were like, oh, well, now we can actually just fire up that base image. And in the book, you talk about really going from bare metal all the way up. You want to not just check your software into source code control, but what do you mean by checking the entire system?
So it should be. Why don't you talk about your test for data center integrity?
Oh, the one by you're prepared to let me and you turn up with chainsaws and explosives and water pistols and go at your data center, and we time how long it is for you to come back live again? Yes. That one?
Right. So this is Martin's test of your operations readiness. it should be possible for you to do that and for you to say, okay, well, no problem. I can bring up a completely working system from scratch using what's in version control plus a bunch of scripts. That should be possible. And that has obvious utility in the case of business continuity and disaster recovery, whatever you want to call it. But it's also really important in terms of actually producing a working system that if you're going to test, if you're going to produce production-like test environments, a lot of the problems we see in organizations is where it takes a week to bring up a test environment, and then there's tickets going back and forth between the infrastructure people and the testers and the developers. And we say, well, no, that's ridiculous. You should be able to do that in a push-button way. How do you do that? Well, you have the declared state of your infrastructure in version control, and tools like Puppet and Chef allow you to instantiate those environments using fully automated processes. And
one thing I do want to throw in this discussion, because I think we have to throw it in whenever we talk about this topic, is we make this slightly annoying distinction between continuous delivery and continuous deployment, which is very important. When we talk about this stuff, we usually talk about cases where typical like websites like Facebook or Flickr, and they are deploying into production multiple times a day. But continuous delivery is broader than that. Even if you can only deploy into production once a year, like when Jez was managing our Go tool and its shrink wrap software, and you could only send it out every so often, you can still do continuous delivery. The test is that the software should always be ready to be able to deploy to production, and that you make the decision to deploy to production purely a business decision, not a technical decision. In fact, many of our clients, I would say most of our clients, tend to deploy into production every 1 to 2 weeks. But the point of using continuous delivery is that you're always ready.
There's an interesting book coming out in a couple of months, which is by the HP firmware team, and they moved to a continuous delivery process. Now, obviously, HP firmware doesn't get released very often, but what they found was they had a different branch for every HP printer, and they worked out their activity, and only 5% of their time was actually building features. The rest of their time they were spending 25% of their time merging between branches. And so they re-architected their systems. So they built the entire firmware on trunk, and the firmware would actually detect what printer it was running on and turn features on and off accordingly. But they moved to a trunk-based development system. They built continuous integration. This is a C++ code base, a large C++ code base, and they wrote automated tests that ran in a virtual machine and then on logic boards to prove that the firmware would actually work. They had 30,000 automated tests, and if your check-in broke some of those tests, it was automatically reverted from version control. They moved to continuous delivery, and it made a huge difference to their process. They were able to get 40% of their time spent on features rather than 5%.
So it sounds like there's two interesting things that happened there. One, that someone identified that there was a problem, right? That 25% of their time is going just wasted. Just using one of my favorite software engineering terms, yak shaving, right? They're not actually doing any software delivery. They're just shaving the yak because it's part of the process. And then the business will to actually make that happen. Now, you say, though, out of kind of one side of your mouth that we should be delivering on a regular basis. We should always have a system that is deliverable. But then here you just give an example right after that where they rip the guts out of an entire system and put the guts back in. There must have been a time when that software was not deliverable. So how do you deal with complete system refactorings and reimaginings of systems while also maintaining a deliverable system?
So I think in the case of HP, I mean, this was in 2008 before the book came out. They were doing continuous delivery, and they didn't know what it was called, but they did it anyway. They rewrote the architecture from scratch. Now, that's not something we'd always recommend. What we do have is a pattern which we've used a bunch of times, which is kind of the slightly crappy name of branch by abstraction. And the idea is this: you want to make a large-scale change to your system. What you want to do is find a seam above that layer, say an abstraction layer, and you have the existing implementation, and you create a new implementation side by side. And that's checked into version control, and you just use polymorphism. You substitute one object for another object, and you do that using a toggle, which could be at build time or runtime. So, for example, software that I used to work on, Go, we were moving from Ibartis to Hibernate in the back end. And what we did is we had the repository pattern, which was a layer over the database access, so that was transparent to the system, and we created a new object which implemented the same interface, and we started implementing Hibernate calls for that. And we did it as a feature was played, as a story was played that required a change to the back end, we would make those changes by porting it over to Hibernate. But we had both of those Some calls would go to Hibernate, some calls would go to Ibartis, and gradually would move methods over from being implemented in Ibartis to Hibernate. But trunk was still releasable. And so we were making large-scale architectural changes. At the same time, on the front end, we were moving from a velocity-based stack to a JRuby on Rails-based stack. And we did that basically using the same process. You'd have some URIs would go /new/ and then the page name, and that would go through the JRuby on Rails stack. Other calls would go to the velocity stack. And it was the same HTML and CSS, so it looked identical. It was just going through a completely different code path. And the only way you would know whether the page you were on was JRuby on Rails or velocity was by looking at the URI and seeing if that new was in there.
So even though the system was deliverable at any time, it doesn't necessarily mean you would deliver it in this kind of middle Frankenstein's monster.
No, we did. We kept releasing it.
You actually did?
Even in that state.
Oh, wow.
So, I mean, that was... We had to do it because we were going to make this large change, and we realized, well, if we do this completely, it's going to take us a year, and we can't do that. We have to release the software.
So that's really interesting to me, because I've sat down with lots of different people, and they've talked about, well, we're going to move from X technology to Y technology. And there's always that feeling that a hybrid is a dirty word. In the ASP.NET world where I live, someone might be going from web forms over to MVC, and they would never think of releasing something that was both. But I think your point is that, well, the URL's fine and the HTML's fine, but most importantly, the functionality's fine. Why not release a hybrid?
Exactly. I mean, it sometimes is very difficult to do, depending on what your technology base is. But if you can, then it comes down to it should be a business decision. And a lot of the time it says, yeah, you may be in the middle of a major shift, but we need to release, so we should.
I think that it's important to point out all that stuff was tested. So we were writing unit tests for all that code. We had acceptance tests that were running through WebDriver to make sure that all that stuff was working. So all that code was tested, and we've definitely prioritized that very, very, very strongly. That's very important to us.
Right.
But you say it's dirty. I guess aesthetically,
from a purist perspective,
right? Yeah, absolutely. But for us, it was more important. It was dirtier to us to be in a state where we couldn't release for a year. I mean, that for me is basic hygiene. That's
really interesting. And your point about these quality gates, because you talk in the book about setting up a pipeline, and even spikes and even crazy new refactorings should still be moving their way through the pipeline. Someone doesn't just go off in a room, close the door, design the new system, and then bring it down from the mountain. Here is the new system.
No, I think I would say it's okay to go out and try crazy new ideas. Those never get checked into trunk. I mean, you can go and create a branch and run a bunch of ideas, but the crucial thing is those get thrown away. The output of that process is knowledge, which you then go to use and actually write the real code. But yeah, any of those things, any big architectural changes, any big features that you're writing, all that stuff should go into trunk, and all that stuff should be tested. And you use your normal process for doing that. You just use good object-oriented principles to make sure that stuff doesn't get run at runtime. And that it's well encapsulated. You follow all the usual architectural principles. And if you can do this stuff, that for me is a sign that your architecture is actually good, that you've practiced, good object-oriented design, that you have nice separation of concerns, that you have properly componentized architectures. When people find this difficult, it's normally because they've got a horrible monolithic ball of mud. And in that situation, this is just one of the problems that you'll experience, is that it will be hard to do continuous delivery.
Yeah, I think it's a good test for a design of a system is, have you thought about how it can be gracefully and gradually replaced? And we should all be thinking about the death of our systems from the earliest days.
Very cool. Well, thanks, guys, for chatting with me today. The book is called Continuous Delivery, Reliable Software Releases Through Build, Test, and Deployment Automation. And it's by Jez Humble and also David Farley. And this is part of the Addison Wesley Signature Series, of which you are the series editor.
Indeed I am. And I've been very fortunate with these books, although I am annoyed that this is yet another book that has won the Jolt Award and I've only ever come second.
And on that bitter note, I thank you guys both, Jez Humble and Martin Fowler, for chatting with me today here at GOTO.
Thanks for having us.
Thanks.
This has been another episode of Hansel Minutes, and we'll see you again next week.